Hi, this video gives you everything you need to know for your constructions unit for your high school geometry class. So a construction is creating a geometric figure with only a compass and a straight edge. That's it. And a straight edge doesn't measure, it's not a ruler, it just helps you make a straight line. But you use the compass to measure. And you use the compass, of course, to draw a circle, or at least a part of a circle, which is called an arc. And so in this video, the way I draw that is that little point, it represents the sharp edge of the compass, and the arc represents the pencil side of the compass. And you use the compass to draw an arc or a whole circle, right? Now the key concept here is that all points of the arc and the circle are the same distance from the center point. And this distance, of course, is known as the radius. And so in this way, you use a compass like a ruler. You use it to measure. So here are all the things we're going to draw using a compass and a straight edge. And when you learn all these, you'll be able to do everything you need to do in your geometry class. So first we construct a copy of a line segment. What I say here for some of these is that it's a basic technique, and that means you use this technique all the time. So to copy a line segment, let's just start with any old line segment, and then we measure that, we set the compass to measure that line segment. And what I recommend is that you actually make a mark on the original line segment, because that way you know that the compass is set right. One of the biggest frustrations in doing work with the compass is that you don't quite set it right, and then your figures don't look good at all. So you want to make sure you set it right by actually making a mark. And then you go someplace else on the paper and you make the mark, make an arc like that, and then you draw the line segment. Now the line segment doesn't have to be the same orientation. We'll do parallel lines later. It just needs to be the same length. Next, we're going to copy a triangle. So here's a triangle, and we do it by just copying the sides. So first we copy the first side, and then we go to one endpoint of that first side and measure the second side, and we don't draw it in yet. And then we go to the other endpoint of the first side and measure the third side. And when you draw it over on this other drawing, you need to make sure that you have a crosshatch. So make these arcs big enough so they will definitely cross each other. Then you fill in the second side and you fill in the third side, and you've done it. Now you can also copy a quadrilateral or any polygon. So here's a quadrilateral, and the way I suggest you do it is you start with the long side and you measure that, and then you draw it. And then you start with one end of the long side and you measure to the first open vertex, and you draw an arc for that. You measure the second open vertex and draw an arc for that. Then you go over to the other endpoint of the first side and you measure to the first open vertex and you draw that, so there's a crosshatch. And then you measure to the second open vertex and you make another crosshatch like that, and then you draw on the sides. And this technique will work for any polygon. So the next subject is isosceles triangles and angles. Now you'll see why I put these two subjects together. First, we're going to construct an isosceles triangle, and this is something very natural to do with your compass. And there's different ways to do it. You can just start with a point and you make a big sweep like this, and you draw a line so it cuts the sweep in 2 points at 2 intersections right here. And then you draw a line from the center point to one of the intersections and from the center point to the other intersection, and you have an isosceles triangle. And you could do this with starting with a line, and then you make a sweep like this, cutting the line in 2 places. And you'll do this kind of sweep like this, cutting the line in 2 places, in other constructions. So this is a good thing to know. And then you draw a line from the center point to the intersections, and you got a isosceles triangle. You can also start with an angle, and you make a sweep across two sides of the angle, and you draw on the third side, which is called the base, by the way. That's the base of the isosceles triangle, and we're done. So now we're going to copy an isosceles triangle, which is just like copying a normal triangle. And so we start with the isosceles triangle, but this time you just measure one side of the two sides that have the same length, and then you measure that and you sweep down, and you can cut the endpoints of both sides. And so you make that sweep over there. You draw one of the sides, then you measure, just like you're copying a triangle. You measure the third side, and you make a crosshatch, and you fill in the sides, and that's that. Now, the reason I want to show you that is very similar to drawing copying an angle. You're just not doing all those steps. So let's start with an angle, and let's draw the first side of the angle over here, and then we cut the sweep through two sides of the original angle, and then we make that same cut. Then we measure the distance between the two intersections here of the sweep, and it's just like measuring the third side, the base of the isosceles triangle. See that? And so we make a crosshatch, and then we draw the second side of the angle, and we've done it. You'll do this copying an angle later in other constructions. All right, our next topic is the equilateral triangle and hexagons. And equilateral triangle, again, is a very natural triangle to draw. It's just like creating an isosceles triangle, but here when you create the third side, this third side will be the same length as the first side. And so you don't have to change the setting of the compass at all. You just make the sweep, and then don't change the setting, and make the crosshatch, and that's it. And you have an equilateral triangle where all the sides are the same. Now, if you need to make a 60-degree angle, this is how you do it. You do an equilateral triangle, and each of the angles is 60 degrees. Now, another very natural thing to draw with a compass is a hexagon. And here you start with a circle, and you don't change the width of the compass at all. You just start anywhere on the circle, and you draw a little arc that crosses through the circle, and you draw a line segment from the center point to that arc, and you keep going around the circle just like this, and that makes a hexagon. So the next subject we have is perpendicular lines. So this is pretty important because this is how you make right triangles and right angles and all that. So the very natural thing to do with a compass is to create a perpendicular bisector. And you'll see what I mean. So let's start with any old line segment. And then what you do is you want to set your compass to be more than halfway across. More than halfway. So set it about that wide, right? More than halfway across. And then you make an arc for that setting above the line and below the line. And then you go to the other side of the endpoint of the line segment, and you don't change the setting, but you use the same setting, and you make a crosshatch. And then you go make another crosshatch on the bottom. And then you just simply draw a line between those two crosshatches, and that is a perpendicular bisector. And what we mean by that is it's perpendicular, it meets at a right angle to the original line segment, and then it also crosses at the midpoint of the original line segment, and the midpoint, and that it bisects the line, it cuts the line in half, so each side is the same length. So that's the easy thing to do. And now the question is, what if you want to make a perpendicular somewhere else on the line, either somewhere on the line or else on the line, or from a point outside the line? So we'll do each of those. First, let's say we want to make a perpendicular at one endpoint of this line segment. Well, what we need to do is we need to make a little temporary line segment so we can do a perpendicular bisector. So the first thing you do is you put the sharp end of the the compass down at where you want the perpendicular line, and then you set it to whatever you want and make a cut on the line segment. Now you make another cut just opposite that, and you may need to extend the line segment so you go out to that other cut. Okay, now you do a perpendicular bisector. So you set it a little more than halfway. You make a arc like that, and you keep the same setting and go to the other side and make a crosshatch like that. Now you only have to make it above or below. You don't need to do two of them because this original line where you want to make the perpendicular line is already there. That original point's already there. So you can make the perpendicular through the crosshatch in that line, and there you have it. You have a right angle. Okay, now if it's out, if you want to draw a perpendicular line to a line outside the line segment, you draw one of these big sweeps that cuts the line segment in two places, and that is your temporary line segment where you do the perpendicular bisector. So you do that, and once again you set it more than halfway, and you draw an arc and draw a crosshatch. You only have to do it once because you already have this line, this point here, the original point, and then you draw the perpendicular line. That's it. Now if you want to make a right triangle, you create a right angle using these techniques, and then you fill in the triangle. So that's it. Our next subject is bisecting angles. This is cutting an angle in half. And I want to show you that first, to show you how the basis for doing this, we're going to create a perpendicular bisector of the base of an isosceles triangle. You'll see what I mean, and that leads us right to being able to do an angle bisector. So we start with an isosceles triangle where we have an angle, and then we do a sweep like that, and there's our isosceles triangle, and we draw in the base just like that. The base is that third side that's not equal to the other two. Now we do a perpendicular bisector of the base. So we use the technique where that we saw on the previous slide. You make a crosshatch above and below, and you draw it. And now what you'll notice is first it cuts this base in half, right? So both sides are the same length. But it also goes through what's called the apex. This is where the two sides that are the same length meet. This is called the apex of the isosceles triangle. So it goes right through it. Now you learn this later, but these two triangles, this one right here and the one over here, are what are called congruent. That means they're the same size and shape. And because they're congruent, the two angles on either, that on either side of this perpendicular bisector are the same number of degrees. They're the same size, and we say these two angles are congruent. And so what we've done is cut this angle in half. And so to do an angle bisector, that means cutting an angle in half. We do the same thing, but we don't need to do all the steps. We first have our angle, we do that sweep, and now we measure, we set our compass a little more than halfway across, and we do a crosshatch, just like we're doing a perpendicular bisector. But we only have to do one of them because we know the apex is on that same line, right? That divides the angle in half. So we just draw it, and there it is. We've divided it in half. So you can see how these two techniques are alike. Now you can use the same technique to get 45-degree angles and 30-degree angles. So let's start with a right angle. You know, we did a perpendicular on the previous slide, and you could do this technique for bisecting the angle, and you get two 45-degree angles. You can start with a 60-degree angle that you do by doing an equilateral triangle, and you do this technique, and you get two 30-degree angles. Now there's another technique for doing this that's interesting, and you'll see this, and that is, let's say we draw a right angle, and what we're going to do is do a big sweep across this whole wide angle, like a half a circle. And then we draw, these two are the same size, and we're going to draw an isosceles triangle. And it turns out that both these angles right here are 45 degrees. Now, we can also do that with 60 degrees, and we draw a big sweep like that. And what I want to say is use some terminology here, that this part of the circle is called the intersected arc by this angle. That's called the intersected arc. And if we draw another angle over here, we extend that line segment out there to the circle, and then we draw a line from a vertex on the circle itself to that same intersected arc. It hits the arc up here and it hits the arc here. That angle is half the angle that comes from the center of the circle. And you could take my word for it, but you might look at this and say, half? Why would it be half? I mean, it's not obvious that it's half. Well, I wanted to show you this because not only it shows you a way to be able to get a half of an angle, but it also shows that it's a way for me to make a plug for geometry. And that is, when you start geometry, you may find, oh, what I'm learning here is so obvious. It's just all this obvious stuff. But some things in geometry are surprising. And this one is surprising. The fact that you could draw an angle to the same, where you have an angle that starts on the circle itself, it's half the angle that starts on the center. Is that really true? And so what you'll learn in geometry is that it is true, and you'll see why it's true, and you'll be able to prove it's true. And you can see on this one over on the left here, this 90-degree angle has this intercepted arc right here, and then the angle over here that's on the circle itself, the vertex is on the circle, hits that same intersected arc, and it's half the value. So this works in any case at any point on the circle. Okay, so the next topic is parallel lines. This is important, and it's really the last basic technique you need to learn. And so some terminology first. Here we have some parallel lines, and if you draw a line across the parallel lines, that's called a transversal. And if a transversal has an angle against each of the same angle across each of the parallel lines, those angles are called corresponding angles, right? And that's what this concept is, what you're going to use for drawing a parallel line. So we start with any old line segment, and then we draw a point where we want to have the other parallel line, and then we draw any old transversal, and what we're going to do is copy the angle, that angle, up here. So we do this normal technique we just use for copying an angle, and we do that, and we make a crosshatch, and we draw that line, and that is a parallel line. So you can use that for doing all these special quadrilaterals that you know from past math classes, like the trapezoid is just two parallel lines and you draw on the side. And to construct a parallelogram, you start with a line segment, and then you put a point where you would like the corner of that parallelogram, and you draw a nice transversal, just like we did up here, that through that point and through the endpoint of that line segment, and then you copy the angle. And when you make that cross hatch, you draw the line. Well, first of all, what I'm going to do is we're going to measure the length of that line, the line segment here, and then we'll measure that same length here. And so you draw a line through the crosshatch for that length, and that's the other side of the for the parallelogram, and then you fill in the fourth side. And you'll learn, and this takes advantage of the fact that the parallelogram the opposite sides of the parallelogram have the same length segment, and you'll learn why that's true, and you'll prove that that's true later in geometry. Okay, for a rhombus, which is like a parallelogram except all sides of the same length, we draw a line segment and where we want the corner of the rhombus, and we draw the first side, and then we measure that first side and sweep down to the second side right there, and then we use the same, you keep the same setting of the compass, and you measure the third side, and this, and you you draw this third side, an arc for the third side, and you draw a crosshatch for the fourth side, and then you fill in the third and fourth side, and that's a rhombus. Now the rectangle, you do exactly the same thing as you do for a parallelogram, except you have to start with a 90-degree angle. So you got to use a perpendicular, you got to draw a perpendicular line using the technique we described, and then you figure out where you want to have the other side of the rectangle, and then you copy the angle and make a parallel line, just like we did on a parallelogram, and we measure how long we want that other side, and then we draw it, and then we draw the fourth side. So that's it. And the square is the same as a rhombus, except you have to start with a right angle, and you mark where you want the square, you measure the first side and sweep to the second side. You use that same setting to mark the third side and the fourth side, and then you fill in the third and fourth side, and that's it. So our last topic is transformations, and you use all the techniques you've just seen to do transformations. Now transformations are something you can do in a future unit of geometry class, and in that unit you may not be using the compass and straight edge. You'll be using other techniques for the transformations, but I wanted to show you that you can do transformations using a compass and straight edge. And there's three transformations: translation, reflection, and rotation. We'll show how to do that. And for each of these, what we do is we start with what's called a pre-image, like any geometric figure, and what we want to do is create another image. And so we have the pre-image going to the image. And the first is translation, and what we do for this is we want to move the geometric figure but not twist it or turn it, right? Not twist it or turn it, but keep it in the same orientation. Well, that means that we have to make sure that our approach is that we're going to, for one of the sides, what we're going to do is we're going to make sure that we create a parallel side elsewhere, right, wherever we want. And then we'll fill in the rest of the triangle. So let's start by creating a parallel side. So let's draw the transversal to wherever point we want this to translate this figure, and then we measure the angle, and what we're doing is copying the angle just like we normally do, and then we can draw the parallel side just like that. So this line is parallel to that line. Okay. Then we measure. Now we're going to copy the length of the first side. So we do that. We measure the length of the first side and we mark it. Measure the length of the second side and we mark it. Measure the length of the third side and mark it. And we fill in the second and third side, and we've moved the triangle, and it's oriented the exact same way. Now reflection is for reflecting this figure across what's called a line of reflection. It reflects it like a mirror across the line of reflection. And the way we do this is we're going to figure out where the reflection is for the three different vertices, And so for the first vertex, we pick this one, and what we're going to do is create a line perpendicular to the line of reflection from that vertex. And so you do that by making that sweep and cutting the line in two places, and then we make a parallel line by setting the compass a little more than halfway and making a crosshatch from one endpoint and from the other endpoint, and then we draw from that original vertex through the crosshatch, and that's our our perpendicular line, right? Our perpendicular line. Then what we have to do is make sure that the vertex over here is the same distance from the line of reflection. So we measure that distance, and then we go to the other side and mark how that same distance on the other side, and that's where the vertex is. Now we do the same technique for the other two vertexes, the other two vertices, right? So here's a vertex, and the second vertex, and we make a parallel line, a perpendicular line from that vertex, and we measure it on the other side, and that's where that vertex is. And then for the third vertex, we make a perpendicular line, we measure it, and we mark it on the other side, and then we fill in the sides of the triangle, and we've made a reflection. And the last transformation is rotation, where with a compass and a straight edge, we can only really rotate it those number of degrees that we can create with the compass, and so like 90, 60, 45, or whatever we can create, and around what's called a point of rotation. So here we are, and we're going to pick one of the vertices to be where we're going to rotate it around. So we're going to pick that one, and we're going to rotate it, in this case, 90 degrees. So what we need to do is first make a perpendicular line to this side of the triangle. So that's what we're going to do. And so we do that by doing the same technique that we saw earlier in the video, and we create a crosshatch and a perpendicular line, right? And so then we measure this first side, and then we mark it, and then we measure the second side, and we mark it, measure the third side, and mark it, and we fill in the triangle, and we rotated it. So this is everything that you'll need to do in your geometry class, and I hope that this was helpful.